So from this simplified equation, we know that the domain is all real numbers, but x cannot be negative 6 or 5/2. We know that negative 6 is a whole, and we know that 5/2 is a vertical asymptote. How do we determine if something has a horizontal asymptote? Has something to do with the degrees. So if we have a fraction with some function on top, some polynomial, and some polynomial on bottom, if the bottom is bigger, meaning the biggest exponent on the bottom is larger than the one on the top, then the horizontal asymptote is 0. Okay? What if those two polynomials have the same degree? You divide the leading coefficients, and that is your horizontal asymptote. What if the top is bigger than the bottom? It could be oblique if it's one bigger than the bottom. How do you find the oblique? You do long division, and your quotient, and you don't worry about the remainder, your quotient is the oblique asymptote. Okay? So in this case, the bottom degree is bigger than the top degree, which means the HA, the horizontal asymptote, is at y equals 0. And the range is really simple. It's everywhere except 0. So your horizontal asymptote determines the range. Your range is all real numbers except y cannot be 0. Okay? Well, we're going to figure out how to graph these today. All right? So in order to graph them, you need to know a little bit about what they look like. And if we have some combination of asymptotes, the graphs can look like this, and like this, like that, or any combination like that. Sometimes it might come up and go through, okay? But that's the basic shape of what we're going to be dealing with, some combination of that. Okay? So one thing we haven't talked about yet is the roots. What are the roots? Well, the roots occur when the top equals 0. Right? We want to know, when does y equal 0? Well, if this equation is y equals, the only way to have a fraction that equals 0 is to have the top equaling 0. Correct? So we set the top equal to 0. What is the only root? Negative 6, but what do we already know about negative 6? It doesn't exist. Right? So the only possible root is x equals negative 6, but we already stated that negative 6 is not part of the domain, so this one has no roots. Which means it does not cross the x-axis. But guess what? I already knew that. If your HA is 0, there's no way the graph can cross the x-axis, right? Because we have, that's not part of the range. Okay? So here's what we do. Okay? So I'm going to draw a graph. I know a couple things. I know that the x-axis is my HA. All right? I also know I have a VA at 2.5. Everybody agree? So 1, 2, 2.5. So I have a vertical asymptote right there. Now this is kind of tough. I'm going to go ahead and tell you right off the bat that this is kind of hard to do until you get the hang of it. So on the left side, it's either going to be this graph or that graph. We have to decide which one. On the right side, it's either going to be this graph or that graph. Okay? So all you need to do is plug in a number and see where does that number land. Okay? So is it going to be above the x-axis or below the x-axis? So let's try it. What would be the best x value to plug into the function? What's the easiest one? 0. Now, the dividing line is this VA, so I'm going to plug in 0. So on top, 0 plus 24 is a positive number. All I care about is positive and negative. Okay? So that's a positive number. And 0 plus 0 minus 120 is a negative number. What is positive divided by negative? Negative, so which graph is it? The bottom graph. Now we do the same thing on the other side. So I need to plug in some number over here. I would stick to a number that's as small as possible and is still easy. 3 would be the number. So let's plug in 3. 4 times 3 is 12, plus 24, and I don't care what the number is. I just care if it's positive or negative. And on bottom, I have a really big positive plus a really big positive. Is that going to be bigger than 120? Well, 8 times 9 is 72, plus 28 times 3. Is it going to be positive or negative? Positive. So positive divided by a positive is a positive, so which graph is it? The top. That's what it's going to look like. We'll get to that. That's a good question. Okay, so look in your book on page page 86. So I don't want to bother factoring any of these because you should already have everything factored. All right? So here is the factored version that we're going to look at. So this has 2 vertical asymptotes, right? So I draw my graph. It's got a vertical asymptote at 3 and at -2. Does it have a horizontal asymptote? At 0, because the bottom is bigger than the top, so my HA is right here. Okay? Now, so the domain is all real numbers except -2 and 3. The range is all real numbers except 0. And if I set the top equal to 0, I get a root. What's my root? 1. So it touches the axis right here. So some people make a chart that looks like this. We have at -2, we have that mark. And then at +1, I have a dot. And then at +3, I have another one like this. So I need to find out on the left side of this -2, is it above or below? So I actually have 4 sections to look at. So I need to find positive and negative numbers inside those sections. So let's start on the left. We need to be left of -2, so let's pick -3. So I'm going to plug in -3. -3 minus 1 is negative, divided by, let's plug it in here, 9. 9 plus 3 minus 6 is positive. What is negative over positive? Negative, so I'm going to put a negative down here. Okay? So I move on to the next section. What's the best number to pick inside there? Between -2 and 1. 0 is the one you want. In this group right here, the best number is 0. So I plug in 0. 0 minus 1 is negative on top. Plug in a 0, minus 6. What is negative over negative? So up here is a positive. Well, I don't even need to do the next one. How come? I know that this is a root. So if it's positive on the left side of the root, does that guarantee it's going to be negative on the right side? Well, now that I think about it, not really, unless it's a double root, right? If this was x minus 1 and x minus 1, then it would actually bounce off. But where it's a single root, I know that this side's going to be negative. Does everybody get that? If you don't get that, then you need to test both of them. So if it's a double root, if one's positive, the other would be positive. What if it's a triple root? Positive and negative. What if it's a quadruple root? Positive and positive, right. Okay? So now on this right side, what number should I pick over here? 4. So let's plug in 4. 4 minus 1 is positive divided by 16. Minus 4 minus 6 is positive. So over here it's positive. Now I have everything I need in order to graph this. So I know where my HA is. It's going to look like that. Look like this. It's going to look like that. Does that make sense? Did that answer your question about the root? Okay. All right. So turn the page. So if I look at the factored version, I don't have any holes, but I have 2 vertical asymptotes. Where are they? 2 and negative 2. Do I have an HA? It's at 2 because the degree on the top is equal to the degree on the bottom. So I divide the leading coefficients, 2 over 1, so up at 2. Now here I have to be a little bit more careful because positive and negative is not going to be enough. What do I need to know? Above 2 or below 2. So this is a little bit harder. When your HA is 0, all you have to worry about is positive and negative. But if your HA is anything other than 0, then you need to make sure it's above that or below it. Do I have any roots? 1 and negative 1. So I have a root here, and I have a root here. So if I make that chart, negative 2, I have an asymptote. Negative 1, I have a point. 1, I have a point. And at 2, I have an asymptote. So now I need to know, is it above 2 or below 2? So I'm going to write a 2 here, because that's my HA. So on the far left side, what should I plug in? Negative 3. So 2 times 9 minus 2 is 16. And then divided by 9 minus 4 is 5. Is 16/5 bigger than or smaller than 2? Bigger than, so I can put a plus up here. Does everybody get that? You guys are doing really well. This is hard stuff. Okay? So now, in this gap, I really don't have a very nice number. Well, I kind of know what it's going to look like, don't I? It has to go through the roots. What else does it have to do? It can't go above 2. What else does it have to do? So what is the only way to stay inside this box and still hit those 2 roots? And it's not really a parabola, but it is an upside down U. So that one kind of does itself. So If I were to plug in 1.5, what would I get? I'd get a negative number, right? If I were to plug in 0, I would get a number between 0 and 2. And if I were to plug in like 1.5, then I would get a negative number. That is the only possibility there. There's no other way to draw that graph. You cannot pass through a horizontal asymptote. If you have an oblique, if your graph looks like this, then you can pass through an oblique. So you could have a graph, I don't know, I'm going to make it up, that looks something like that. Well, my vertical asymptote would have to move, but it is possible to go through an oblique, but you cannot go through an HA or a VA because they're not part of the range. So in this case, there's no choice but an upside down U. So if you want to, you can go ahead and plug in those numbers, but we didn't need to. Okay? And now I need to figure out what's on the right side. So I'm going to plug in 3, and it's going to be exactly the same as negative 3, right? You're going to get 16/5, which is bigger than 2, so positive, so my graph's going to look like this. Okay? Which is exactly what you see there on the final sketch. So they found the y-intercept. Sometimes that helps, but you don't really need it. All right, turn the page. Okay, so if I looked at the factored version, I end up with, notice the top does not factor. So I have a VA at -2. So at -2, I have a vertical asymptote. Horizontal or oblique? Oblique, so we would long divide, and I'm not going to do it. They give it to us. X minus 4. So when I long divide, I get x minus 4. So the graph of x minus 4 starts down 4, and then goes up 1 over 1. So here's the oblique asymptote. Okay? And then they do this chart here. So if we pick a negative number like -3, let's plug in -3. 9 plus 6 plus 3 is positive, and -3 plus 2 is negative, which equals a negative number. So over here at 3, it's negative, so it's going to be down this way. Is that? Oh, I got it wrong. Okay, so, and then if we do the right side, see, these are so hard. Oh, the whole graph is negative. So, do you want my recommendation for the obliques? Well, you have to do them. I would just graph them in your calculator. Really, the obliques they're hard to do. So if you end up with an oblique, I would just put parentheses around the top and the bottom and graph it in your calculator. Okay? All right. Well, the one thing we haven't talked about is a hole. Well, we never actually graphed one that had a hole in it. So here we have a VA at 3, and we have a hole at -3. Okay? Oh, I got that backwards, huh? Sorry. So the VA is -3. Does this have any roots? It has a root, but it's a whole, so it doesn't count. I guess we kind of did one of these. I just forgot to put the whole on it. And do we have an HA? An HA at 0. So I have an HA right here. So I need to find out if it's positive or negative on the left side. What should I plug in? Negative 4. So negative 4 minus 3 is negative 7, or just negative, over negative 4 squared is 16 minus 9 is positive, which is negative. So it's going to be down here. Now, what's the easiest one on the right side? 0. So 0 and 0, I get negative over negative is positive. So it's going to look like this, but there's one thing I'm missing. There's a hole at 3. Did I already show you that? Oh. Okay, I thought I didn't, but I did. Yep, circle where the hole is. Yeah. And technically you should draw it and stop and draw it, but you're going to already have the graph drawn, so just circle the hole. So let's do one from start to finish. Actually, let's make it, yeah, let's do this. This is okay. All right. So I factor both x minus 3, x plus 2, x minus 3, and x plus 3. Oh, you're right, it's minus 2. Thank you. That's what I meant. So, let's start with the domain. All real numbers, but x cannot be plus or minus 3. So, negative 3 and... So, the minus 3 is what structure? A VA. The plus 3 is what structure? A whole. Okay? For the range, it's all real numbers, but y cannot equal... No, it's only 0 if the bottom is bigger than the top. If they're the same size, 1 over 1. The leading coefficients on both of those are 1, so 1 over 1 is 1, and that is my HA. Okay? And what about roots? Three and 2, but 3 is a whole, so the only root is x equals 2. Okay? So we draw the graph, and then we label what we can. We have a VA at negative 3. We have a horizontal asymptote at 1. So that's my HA at 1. And I have a root at x equals 2. Is that a single root or a double root? Single, so if one side is up, the other side is down. Right. If it's an even number, it bounces off. If it's an odd number, it goes through. Okay, and this is a single root because there's only one of those. Okay, so now we're plugging in numbers and we're trying to figure out if it's above 1 or below 1. Because my horizontal asymptote is at 1. Okay? So what should I plug in for this left side? Negative 4. So I plug in negative 4 and I get 16 plus 30 plus 6 is what sort of number? Oh, 4, whatever. 20. It's bigger than 1, right? So I'm going to write, well, I better write it out, huh? 36, 42. Okay, now I plug in 4 and I get 16 minus 9, 7. And 42 over 7 is, which is bigger than 1. We don't really care about positive and negative here. We're talking about bigger than 1 and lower than 1. So it's going to be up here. Okay? So now, um, anybody figured out the rest of the graph? Chase, what's it going to look like? Do you want to come draw it? Well, let's try it. So what number should I plug in between the VA and the root? Plug in 0. So 0, 0, 6. So I have 6 divided by -9, which is less than 1. So it's going to be below. And then I know it's above on the other side, but I also know it can't reach 1. So it's got to start negative, go through the root, and then level off. And I also have a hole at 3. Now, I already knew it was going to look like that. How did I know? Well, I have this box, and I had the root. That is the only thing it can look like. Because I know it has to approach the asymptote in that direction, and it has to approach the asymptote in that direction. It also has to hit the root. So that one, you could just look at it and figure it out without plugging in the numbers. Okay. So go ahead and do the graphs for page 90. And we might work on some of this tomorrow, too. Hang on a second.